How we can observe two black holes colliding. The cataclysmic event of two black holes colliding will undoubtedly go down in history, but to actually witness it happen? Astonishing. In fact, a collision of two supermassive black holes is expected to take place in just a few years from now. And when I say a few, I mean we might only have to wait 3 years from now at the earliest. But how exactly are we going to observe this momentous event? Because black holes are, well, black. We can't see them with the naked eye. And if they're billions of light years away, information isn't as easy to come by as if they were next door. So before we get into anything else, let's dive into the how first. As if in a cosmic boxing ring, two supermassive black holes can be seen circling each other in a galaxy far, far away. Because of gravity, these black holes seem to be in a death spiral, plunging inward toward a catastrophic collision and eventually creating a single black hole. But how did the astronomers know that a collision would happen without even seeing one? It's because of gravity. Since it's the event's origin, it will also be the way for astronomers to detect it. When two black holes spiral into each other, they create ripples through space-time. These ripples are what we call gravitational waves. Although Albert Einstein first proposed the idea of gravitational waves a century ago, it took a long time for their existence to be proven. This is because gravitational waves are a byproduct of general relativity, which paradoxically treats space-time as if it were a fabric that could be swayed by massive objects, such as black holes and neutron stars. But in 2016, that doubt faded away. The Laser Interferometer Gravitational Wave Observatory, or LIGO, as it is more commonly known, made headlines around the world when it announced the historic detection of gravitational waves caused by the collision of two black holes. This is how LIGO helped prove Einstein's intriguing theory that spacetime is a fabric that can be distorted by gravity, like a coin dropped into a lake, causing ripples to spread across the surface. Now going back to the two supermassive black holes, as they get closer, they'll continue to emit more giant gravitational waves. When they get close enough, they can no longer avoid being pulled in by the other's gravity and will combine to form a single, more massive black hole. They'll create waves, and astronomers are working hard to try to detect these waves as they ripple through spacetime. However, at the speed of light, what the scientists are observing has already happened. Meanwhile, space and time will be disrupted by those ripples, but by the time they reach our galaxy and Earth, neither the waves nor the collision of the black holes will be a threat. In fact, some astronomers think we're about to witness what has been called one of the most highly anticipated events in modern astronomy. Observations of fluctuations in the light coming from the center of the galaxy tell them that it appears to be two supermassive black holes hurtling toward each other in a supermassive collision. Not only that, but they have combined a mass of about 2 million suns. In 2015, the first black hole collision was detected because of the gravitational waves it created. However, the gravitational force from the event continued to ripple out for years after it had occurred. Therefore, astronomers were only able to detect it after it happened, not at the instant it occurred. If this is the case, this will be the first time for astronomers to actually witness black holes colliding at the galaxy's core. Right now, the galaxy's light fluctuations might look like two merging black holes. There are other possibilities, though. There will always be questions, because that's how space and all its mysteries work, and that is just the way things are. In some more terrifying news, scientists have found a black hole close to Earth in our own galaxy. Click the video on screen now to find out more. Thanks for watching.